So welcome to today's session where I am going over ellipses. Let's basically start with the definition. An ellipse is the set of all points x, y in a plane, the sum of whose distances from any two distinct fixed points or foci are constant. Last time I had to teach this, I was like, oh, is it foci or foci? It's pronounced foci, even though it's plural for focus. But it's not pronounced foci, it's foci. Really weird. Not sure why that is. I did look it up just to make sure I was pronouncing it right. So basically it means that the distance from, you get 2 points, you have foci, a focus, there's 2 of them. And let's say you had a pencil with a string between the two. And if you just had one string and it was wrapped around your pencil and you just kind of, circled around the pencil trying to go against the string as far as you can, you would make an ellipse. And so the sum of the distance is constant. So the length of the string is the same, but the distance from any one of the foci is not constant. That changes, but their sum is constant. So d1 plus d2 would be the string going around your pencil, and your pencil would wrap around, and that forms the ellipse. A circle is a special form of an ellipse. An ellipse is not a circle, but a circle is an ellipse. So, I think I mentioned that during my live session or the introduction. So as far as the ellipse goes, because we don't have a radius because the distance is not constant, we have what is called the major axis and the minor axis. So the major axis is the longer of the two. So the larger distance is called the major axis. And then the vertices are the 4 points on those axes. So we usually just refer to the vertices in regards to the major axis, but there are ones on the minor axis as well. So there are 2 types. There's when the major axis is horizontal or when the major axis is vertical. So this is an example where it is horizontal, so that would be what it looks like. And then this is the formula. So you have x minus h and y minus k squared. That's the center. H and k is the center. So that's very similar to the equation of a circle. What's different from the equation of a circle is that instead of equal to the radius squared, it's equal to 1. And then each of the parts are divided by a value, a squared and b squared. So the locations of the foci for major axis horizontal is h plus or minus c. So c is this distance from the center to one of the foci. So that's C in red. And so the foci are on either side of wherever the center is. This example is at the origin. And then the vertices are H plus or minus A. So A is a larger distance. A is bigger than C. And so then A squared minus B squared gets you C squared. So that's essentially kind of coming off of the quadratic formula. You can see roughly they're showing how it makes these, not the quadratic formula, the Pythagorean theorem. But you can see how you get these triangles here. If you want the theory of where all that comes from, you are welcome to go find that. It's in the book. They explain. You can see B here is this distance over here, and then C is that smaller distance. And so, you can form triangles, figure it all out. But I wouldn't worry too much about that. I would just worry about these 4 formulas and then the formula for the major axis horizontal. When it's vertical, it looks nearly identical except that the b squared and the a squared flip-flop. So we had a squared and b squared, and a squared is under the x, b squared is under the y. When it's vertical, b squared is under the x, a squared is under the y. So that's the only difference in the formula. The center is still h comma k. And the major axis is 2a, the minor axis is 2b. And that is the same regardless of whether you're vertical or horizontal. So I have, these are all pictures from the book, but I have them next to each other so you can see that 2 times A and 2 times B, those are the same regardless of which form you are in. The only thing that changes is where A squared and B squared are in your formula. And then, of course, what changes is that if it's vertical, you're adding C and K to the K, C and A to the K part instead of the H part. But everything else stays the same. So it's very, very similar. The most common thing that I see people do is they get confused on whether they have one that's horizontal and vertical and they use the wrong formula. So I would just make sure that you look at where your points are so you can determine whether this one's a vertical or is horizontal one. And just because the B squared is under the A squared, just in this case, B is less than A, which makes sense if you look at my previous thing. A is the long distance here, and then B is this vertical, it's smaller than A. So basically the larger number always gets put underneath the axis it goes with. So for horizontal here, the longer part is the A squared, so that goes under the X. Here, A squared is the longer part because that's the major axis, so now it goes under the Y because the Y is the major axis. So that's one way to remember which one is which. So we have something that's called eccentricity. So eccentricity measures the ovalness of an ellipse. Basically, how oval is it? They're technically an oval and ellipse are not exactly the same thing. So that's why ovalness is sort of in quotation marks here. But it gives you a good, it's a good, everyday definition. So the eccentricity of an ellipse is the ratio E equals C over A. And E is always between 0 and 1. So if it's a perfect circle, your E is close to 1. And then if it's, the more stretched out it is, the bigger it gets closer to 1. So it starts close to 0. I think I might have accidentally said 1. Circle, your E is close to 0. And then as it gets stretched out, it gets closer to 1. Okay, so now let's actually do some examples here. So example 1, find the standard form of the equation of the ellipse with the given characteristics and center at the origin. So I like to draw a picture so that I have an idea of what's going on here. So my center is at the origin, and then my vertices at plus and minus 8. So the vertices are the parts that actually are on the ellipse. That's a terrible ellipse, but it's what you need to know. And the foci are then at -4 and 4. So this is a horizontal axis for an ellipse. So we need to know that by drawing it. So you draw the vertices. We generally refer to them based off of which is the major axis. So if the vertices here are on the horizontal, then that means it's a horizontal ellipse. So let me just write down our formula for a horizontal. It's x minus h squared over a squared plus y minus k squared over b squared equals 1. So we need to find out what a squared and b squared are. We know h and k because that's the origin. So we need to figure out a squared and b squared. So this is where we're going to use the fact that the major axis is equal to 2a. So the major axis equals 2a. And our distance of the major axis, so that's basically the distance between the two vertices. So you can say, so we've got 8 minus -8 is equal to 2a. So 16 is equal to 2a, which gives us a is equal to 8. So now we know what a is. And we need to figure out what c is. So we can find that based off of the foci. So the foci, that formula is h plus or minus c, comma, k. So since h is 0, that plus or minus must be equal to c. So c is equal to 4. So now we've got a, we have c, but we need to find b. And so that comes from our formula c squared equals a squared minus b squared. So now we're going to plug in numbers. So c squared, c is 4, so c squared is 16. A squared, so 8 is a, so 8 squared is 64. And then minus b squared. So 16 minus 64, that gives us negative 48, which is negative b squared, which means b squared is equal to 48. And now we have everything we need to write our equation. So x minus h is 0 because we're at the origin, so we have x squared over, and then a is 8, so a squared is 64 plus, and then our k is 0 because we're at the origin, so that's y squared over 48. Notice I don't have to take the square root or anything, so you don't have to worry about that. And then that's equal to 1. So once you figure out all your values, it's not so bad. The hard part is probably figuring out what a, b, and c are and making sure you have all three of those so that you can write your equation. Okay, so here's example 2. Find the standard form of the equation of the ellipse with the given characteristics and center at the origin. Okay, so I'm going to draw. This time my vertices are plus or minus 6 on the y. So 6 and negative 6. So that's telling me I'm having a vertical ellipse. Now they're giving us a point. It passes through 1, 4. Okay, this is not to scale, but I'm just putting that on the graph. So this is a little different because we have 1, 4, but we don't really, just like, what do you do with that? Well, let's start with what we know. We can find the major axis. The major axis is 2a. And so that's the distance between our vertices. So 6 minus negative 6 is 2a. So that's 12 equals 2a, which gives us 6 equals a. Now you may think it's silly that I'm doing 6 minus negative 6, but if you have something that's not centered at the origin, you may need to do that calculation. So otherwise you can just see clearly that the total distance there is 12. Okay, so I've got A, and the center's at the origin, so let's just see what we know so far. So since the center's at the origin, we got x squared over a squared, so that's over 36. Then y squared over b squared, which we don't know, and that is equal to 1. Now, in order to find c, we would need the foci. We don't know the foci. We're not given that information. We're given a point. So what we can do is plug 1, 4 into our equation. So I can plug that in for x and y, and then that will allow us to solve for b squared. So the x value is 1, so that's going to be 1 squared, which is 1 over 36. And then y is 4. 4 squared is 16, so that's going to be 16 over b squared is equal to 1. And so now we want to solve this equation for b squared. So I'm going to eliminate fractions by multiplying both sides by 36b squared, because it will just make things nicer. So let's just eliminate fractions. So that will give us b squared plus 36 times 16, which is 576, equals 36b squared. I'm going to subtract b squared from both sides, so that's 576 equals 35b squared. I'm going to divide 576 by 35. Okay, so that actually comes out to a nasty thing. 576 over 35, it doesn't divide evenly, it equals b squared. And we want to reduce that. So I'm going to just let my calculator reduce that. If it does, wait a minute, did I multiply something wrong? Because that did not work out. 16 times 36, 576. Subtract 1, 36 minus 1, that's 35. Okay, somewhere in here I had to have made a stupid math error. This is supposed to come out nicer. 1 times. Okay, where did... Oh, I see what I did. Okay, so I made a mistake that you guys probably make all the time, and I just didn't even think about it. So, this is a good learning experience if you're not careful. I use the formula for the horizontal. See, what happens is if you do that and it's a vertical, it's not going to work out. The horizontal, I need to make sure, you have to put them in the right order. It makes a big difference here. So I've got x squared over b squared plus y squared, that's over 36. This makes a huge difference. Okay, so now I'm going to plug in my 1 and my 4. So I got 1 over b squared plus 16 over 36 equals 1. We're still going to do the same steps. I'm still going to multiply by 36b squared, but this is going to be very different. So if you're getting something that comes out really nasty, that could be what you have done wrong. So we get 36 plus 16b squared equals 36b squared. Okay, that looks much, much, much better. Subtract 16b squared from both sides. We get 36 equals 20b squared. So then 36 divided by 20, that's going to give us a fraction. And we can reduce that. So that just 36 over 20 reduces to 9/5. You can divide them both by 4. That looks much, much better. Okay, so now we've got our b squared. We know our a squared. So now we can write our equation. So x squared over b squared. Oh, that one corner, it never likes having me right there. I don't know why. X squared over 9/5 plus your y squared over a squared, which is 36. And that equals 1. Or we can write this as 5x squared over 9 plus y squared over 36 equals 1. So don't do what I do and put your a squared and your b squared in the wrong part because you're using the horizontal equation instead of the vertical. It's very easy mistake to make, especially if you're not thinking about it. It's exactly what I did. I did the wrong thing. So be very, very careful about that, or you're going to run into what I did. Okay, so moving on to example 3. Find the standard form of the equation of the ellipse with the given characteristics. This time we're not centered at the origin. So now this is going to be a little different. We have a center at 2, -1. So let's say roughly there. They're giving us one vertex, 2 1/2, which means then if we go in the other direction, it should be roughly the same distance. So it's going to look something like this. And then a minor axis length of 2. So it's giving us not the major, but the minor. So again, this is vertical, so I need to make sure. Maybe the best thing to do is to write the formula down. X minus h squared over b squared plus y minus h squared over a squared equals 1. So that's the one for the vertical. So you can make sure that you use the right formula. Okay, so we need to find a squared and b squared. So we know the minor axis, and that will allow us to find b squared because the minor axis is equal to 2 times b, not a. So the minor axis length is 2, so that's 2 equals to b. So that tells us b is equal to 1. So we know b. Now we have to figure out a. And we can figure that out because we have actually part of a. So 2a is the major, and half of that, of course, is a, and that's the distance from the center to the vertex. So since that's our y values, we can find a by subtracting those values. So 1/2 minus -1 is giving us a. So that's half of the major axis. So you can see that's why I'm doing that subtraction. That's 1/2 plus 1. So that's 3.5. I mean 1.5, which is 3/2. Misspoke there. So 3/2 equals a. So now we have our b and our a, so now we can plug it into our formula. So x minus h, so our center is h and k, x minus 2 squared over b squared, so that's 1, plus y, oops, it's supposed to say k, not h, y minus -1, so that's y plus 1 squared, over a squared, so that's going to be 9/4 equals to 1. And then we can simplify or rewrite this slightly. So it's x minus 2 squared plus 4 times y plus 1 squared over 9 equals 1. Okay, so now example 4. This one is going to be longer. I actually have 2 slides for this one because I know it's going to take a lot of steps. Find the center, vertices, foci, and eccentricity of the ellipse. So they're giving us the equation of the ellipse, but it's not in our standard form. This is completely multiplied out. So in order to figure out all of these things, we need to complete the square so that we can put it back into the form that we work with. So completing the square, in order to do that here, we need to group the x stuff together, the y stuff together, and then put the constant on the other side. So I'm going to start with, we have 9x squared minus 54x plus, and then we have 4y squared plus 40y, and then I'm putting the constant on the other side, so that's -37. Now, if you remember completing the square, we always have to get rid of that value in front of the squared term first. Now, in this case, you can do that by factoring out values. So with the x squareds, I can factor out a 9. So that would give me 9 times x squared minus, let's see, 9 times 6 is 54, so it's minus 6x. And then out of the 4y squared plus 40, I can factor out a 4, so that gives me y squared plus 10y, and equals -37. Now I'm leaving these gaps here so that we can do the completing the square process. We're going to do these inside the parentheses here. So when you're completing the square, you take half the middle term, square it, and that's what you add. So half of negative 6 is negative 3. Negative 3 squared is 9. So I need to add 9. But if I add 9 and I don't do it to the other side, I'm changing the equation. So I'm also going to subtract 9. I didn't add 9 to the right side because I have that 9 outside of the parentheses, so that messes with things. So I basically added 0 here. Just bear with me. This will make a little bit more sense. Now I'm going to do the same thing with the next group I have. Half of 10 is 5. 5 squared is 25. So I'm going to add 25 and subtract 25. Now the next thing I'm going to do is take this 9 and multiply it by the negative 9, and 4 times the negative 25, and take only that term out of the parentheses. So that will leave me with 9 times x squared minus 6x plus 9. And 9 times 9 is 81, so minus 81. So I'm just bringing that last part out of the parentheses and leaving the rest of it. And then I'm going to do the same thing with the next set. 4 times 25 is 100, so that's minus 100 equals negative 37. And I'm doing that so that I can have my trinomial that I can factor. So this is going to be 9, and then this factors to x minus 3 squared, and then minus 81 plus 4, then this factors to y plus 5 squared minus 100 equals negative 37. Now we want to put all the constants on the other side, so I'm going to add 81 and add 100. So I get 9 times x minus 3 squared plus 4 times y plus 5 squared equals negative 37 plus 81 plus 100 gives us 144. So now we're getting closer to the form of ellipse. To really have something, we need to have it equal to 1. So now I'm going to divide everything by 144. And I'm going to write this on the next slide. So when you divide everything by 144, let's see, we get 9 over 144, which reduces to 1 over 16. So I'm going to write this up here. We have x minus 3 squared over 16 plus, and then we had 4 divided by 144, which that actually as a fraction reduces to 1 over 36. So that's going to be y plus 5 squared over 36 equals 1. So now we have our equation. We need to find the center, the vertices, the foci, and the eccentricity. So the center is h comma k, which is 3 comma negative 5. So with that one is, once you have it in the right form, you can read that off of the equation. Now the vertices. So the vertices, we have to figure out first, is this a horizontal or a vertical? So the bigger number is under y, which means this is a vertical ellipse. So that will tell us which formula we use for the vertices. That means we're adding to the vertices. So we have h comma k plus or minus a. Because the vertices, you add a to them. So our vertices are 3 comma negative 5 plus or minus. Now a is the number underneath the y term. That's a squared. So I should write that. So we have a squared equals 36. So that means a is 6. So this is negative 5 plus or minus 6. And then if you want, you can find the two separate vertices if you want, but it's completely fine to read them like that, or to write it like that. Now, next is the foci. So the foci, that formula for something that is vertical is h comma k plus or minus c. So we need to find c. We don't have c, we have a squared and b squared, but we can use those to find c. So c squared is a squared minus b squared. So c squared, a squared is 36, b squared is 16. So 36 minus 16, that gives us c squared is equal to 20, which when you take the square root, you get the square root of 20, which is square root of 4 times 5, which is 2 square root of 5. So now that we have c, our foci is 3 comma negative 5 plus or minus 2 square root of 5. And now the last thing here is to find the eccentricity. So that darn corner doesn't want me to write on it. It just disappears. I'll try to fill that in afterwards. So that formula is E equals C over A. So C is 2 square root of 5, and A is 6. So that's the square root of 5 over 3. And so now we found the center, the vertices, the foci, and the eccentricity. So if you have any questions on any of this, of course, you are welcome to email me or call me, send me a Hangouts chat. Hopefully this wasn't confusing for you. It's just a matter of keeping track of all the formulas and whether you have a horizontal or vertical ellipse. I do recommend having this handy so that you have the right formulas. And the same thing for the vertical, so that way you can have the comparison, and once you identify which one is which, you have that available to you. So looking forward to hearing from you if you have questions, and I hope you have a great day.